Okay, we're going to do our cosine parent function just to keep it consistent. Again, I could have used f of theta equals cosine of theta. And then we're going to change our axes again. So starting at 0, and then 1, 2, 3, 4, that's pi. 1, 2, 3, 4, that's 2 pi. And then 1, 2, 3, 4, that's negative pi. 1, 2, 3, 4, that's negative 2 pi. And then again, we just need to go 1, 2, 3, 4 from 1 to negative 1 because of our amplitude. Okay, now this time, as we're going around the unit circle, 0, pi over 6, pi over 4, pi over 3, using our blue radians there, this is cosine. So I'm going to use the x coordinates. So I'm going to use 1, square root 3 over 2, square root 2 over 2, 1/2, 0, negative 1/2. We're going to do that all the way around. Now, I'm going to show you the way I actually do it. I don't actually plot my pi over 4s. I just plot my quadrantals. Because what the quadrantals are going to do is going to give you the overall shape, and then you can fill it in because you know it's that smooth, curvy U. So quadrantals, I mean the pi over, the ones that are on my axes. So I'm going to do 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, the graph of sine and cosine are going to look almost identical except for where they start. Sine starts at 0, cosine starts at 1. Now here's what's going to happen. I'm going to start at 1, then I'm going to go to 0, then I'm going to go to negative 1, then I'm going to go to 0, and then I'm going to go back to 1. That's what's going to happen. Every other one is going to be 0, and then the ones in between are going to alternate 1 or 0. Okay? Now, again, you don't even have to memorize it. You know this point is 1, 0. 0, 1. Negative 1, 0. 0, negative 1. Back to 1, 0. Okay, so my cosine's going to go from 1 to 0. I almost went to pi. Oops. That's pi over 2. Let's mark our pi over 2's. To negative 1. To 3 pi over 2, so 0. Back up to 1. So it looks like it's a lot different than sine, but watch what happens when I go backwards. Negative pi over 2, 0. Negative pi, negative 1. Oops, darn it. 2 mistakes on this one. Negative 3 pi over 2, 0. And then negative 2 pi, 1. Ignore that point. I just graphed a point wrong. So this would come back down. This would come back down. So my full cycle for this one, if I start here and end there, it's also 2 pi. And you can see my amplitude is also 1. My domain is all real numbers, and my range is negative 1 to 1. If you took this graph and you just started it here and here, do you see that that's the perfect sine graph? So all cosine is sine shifted to the left or to the right, depending on how you look at it. Okay? All right. So this time my x-intercepts are going to happen at 0, at pi over 2, at 3 pi over 2, and so on. Positives and negatives. That's not true. Not 0. I was thinking maxes and mins. So pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. The intercepts are going to happen, you can't even see it. The intercepts are going to happen at the odd roots, or odd multiples of pi over 2. The y-intercepts the y-intercept is going to be 0, 1, because I'm starting at 1. The relative max and mins, again, the y is going to be plus or minus 1. So max here, min here, and it's going to happen at 0, pi, 2 pi. So that one's going to happen at all of my multiples of pi. There are no max or absolute max or min. It is continuous. Smooth curve. My domain is all real numbers, and my range goes from -1 to 1. Again, the increasing, decreasing, positive, negative, it's not that it's difficult to see. I'm increasing here. I'm decreasing here. I'm increasing here. I'm positive here. I'm negative here. I'm positive here. It's not that it's hard to see. I just don't want to go over the notation for it right now. Okay? If that makes sense. Now, symmetry. Let's talk symmetry. So when I take this, if I fold it along the y-axis, my left and my right match up. So this one has reflectional symmetry about the y-axis, which means that it's even, which means f of negative x is the same as f of x. In other words, f of pi and f of negative pi have the same value. Again, our end behavior is oscillating. I don't want to go over that notation right now. So that is it for our cosine.